Hello everyone. So I'm here to talk about question answer model. This experiment was performed by Dime, and this experiment basically has two parts to deal with. One is the research which we had done prior starting to deal with the implementation of question answer model. So in the research part, we basically read a couple of research papers which deal with QA model, and then figured out what kind of architecture they had used and what kind of mechanisms and layers they had used for implementing and a chatbot in a real time basis. And the second part deals with implementation of the QA model, and we used Kera setup as our platform to implement this model. So as you can see here, the question answer using deep learning or unified. So if you click on anything, you can find the data set used and the methodology, the approach, and the models used and key conclusions along with the link to paper referred. So reading this, even you can get idea about what is exactly happening in the QA model and how people have gone about. So these are some very famous papers that you can refer to and understand more about this problem scenario that we're talking here. And let me just straight go on to our implementation part, because this you can read it as well. So now, implementation of the QA model. So the first thing is, what is a QA model? So the input that we give will be the question along with the context. So the answer, when a bot answers, so the answer will be from the context related. So it is kind of like understanding what is there in the context and finding and relating it to the question and then giving an answer to it. So the dataset that we used for this experiment was Squad dataset provided by Stanford, and the platform that we used was Azure VM, which gave us like one GPU with 12 memory gigs, and now our model architecture. So we used our final model, which we used for the deployment, was bidirectional LSTM with attention mechanism. So here are the steps performed, and now I can tell you what is exactly there in the model architecture. So first, as we know, we have two inputs, the question and the context. So we basically creating an embedding layer in the first place for both question and the context, and next we are adding a bidirectional LSTM layer and then giving an attention mechanism for both the question and the context, and then concatenating them and giving dense layers for our answer beginning and answer ending, and then finally we get the answer. So what do we get finally is basically the interval, that is the beginning and the ending interval, and then later on with that interval we extract the answer text with the help of token from the test data. So here, now why did we choose this model? Why choose the bidirectional LSTM model? So what happens in an LSTM model is that it is usually good and it deals well with text data, we all know that, but it takes only the past information. So what happens in a bidirectional is that it takes care even about the future information. So it connects two hidden layers of opposite direction to the same outputs. So layers are basically duplicated so that it will be like there will be two layers side by side instead of just one, which is usually there in an LSTM. And usually what happens here is the neurons are split such that like half of them take care about the future and half of them think of the past. So for a problem which deals with question answering and using the context, it's always nice if we have the information about the future and the past so that our prediction will be more oriented. And what is attention mechanism? So attention mechanism, what it basically does is, when there is a huge text, say for example, so you won't know if the text is about like 4 5 lines, you won't know where to exactly concentrate, especially when giving an output answer. So attention mechanism makes sure that attention is given more to the relevant information, and it will discard your noise. So it's very useful for such a problem which deals with answering for a particular question, because you'll have too much noise. And these are the, we have also given what are the best hyperparameters we received. You can just check them here. We used cross entropy loss, and now we'll see what are the evaluation metrics used. So we used F1 measure and exact math score. Exact math score is where the answer you've got is exactly same as that of your truth answer, and F1, it both of them basically deal with the model's accuracy, and F1 uses the precision and the recall to give a overall score, which is about a range of from 0 to 1, 0 being the very poor score and 1 being the highest. And now let's talk about the prototype implementation. So as we know, the prototype we had used is bidirectional LSTM with attention. So talking about the implementation, first step anyone goes about is pre-processing. So our data was square data, as we'd already discussed about, and the pre-processing we used two methods for implementing them. So one is where we had pre-processed the train and the test data separately, like we divided them into question, answer, context, id, the text, and then vectorized them and stored in a hy file, and so that the files can be used whenever we want to implement any model, and we need not waste time in importing or vectorizing every time. And one more method was we created separate modules for each pre-processing, so that we could just import them and use for model creation or while implementation. Now here again it talks about why LSTM with attention apart from all the other models which we had already discussed, and how do you want to improve this model further. See, now the model accuracy is about 88%, and it gives comparatively nice results which can be accepted. But to get perfect answers, because we know people deploy bots in area where they need entire where they want to eliminate customer support or something, so answers should be relevant and 100% accurate. So for that, we could possibly have a better system configuration and increase more number of epochs and make a more complex structure, like add one more layer or ensemble it to get a better performance. And the code for our final record is given here. You can find it here. This is the code given, bidirectional LSTM. You're creating the word embeddings that we created was with the help of Glove, and we used a 100-dimensional Glove text for creating the embedding layer. This is the model created, and the epoch which we ran, and predictions. You can just find them here. And the next step would be to discuss about the model performance. So as you can see, the model performance, we have plotted the accuracy and loss for both the pointers, I mean the beginning answer and the ending, to just visualize the accuracy that we get. And F1 score, as we know, is 0.94 here, which is a pretty good score. And also, now if you want to see some sample question answers, you can see them here, like from which country did the noise originate, with the context is given a very good answer, Normandian region, France, so which is actually correct. And next we'll talk about the one example that we have here. The question asked was, who was Duke in the Battle of Hastings, with the context it gave us this answer. So this is one of the sample. For more sample files, you can find our links that we have given. And if you want some other models we had implemented prior to choosing this final model, you can find them here, each of them. And they're all Jupyter notebook files where you can just run and get a clear idea about it. So we had performed a number of models, LSTM, GRU, and without attention, with attention, and everything, and then come to a conclusion that this would be chosen as the best model. And we have also given you the steps to replicate the experiment, so that you can also visualize the model, how it goes about, and get a clear picture. So here is the end of this experiment. So for any further doubts, you can leave a comment below this video so we can get back to you. Thank you so much.